Hi there. In this series of videos, we're going to start talking about gluconeogenesis and glycogen. So let's start with some basics about gluconeogenesis. So these are the topics we're going to cover in this series of videos. This is going to be a short video just talking about the overview. Um, of course, gluconeogenesis is the making of glucose. I mean, we spend a lot of time seeing how glucose is broken down. Well, many times we need to make it. So how is that made? We do uh, make a lot actually, and for the most part in the liver, all our cells can do some, but the liver makes quite a bit. And as you'll see, it uses lactate actually, a fermentation product to do it. So where does it fit where does gluconeogenesis fit in our general scheme of of metabolism? Well, obviously it's in this part here. So we're going to take some oxidized smaller precursors and make them into something bigger and more reduced, and that's going to cost us money now. So this is where we're going to spend the reducing power that we made from the pentose phosphate pathway and the energy currency in the form of ATP that we got, from oxidative phosphorylation shown here. So these are the reactions, the 10 reactions we had seen in glycolysis. So as you can see, many of them actually are reversible. So you don't need to worry about it. You can go backwards, except 3 of them that are not. And one of which is pyruvate. Pyruvate kinase. So the last one, going back to phosphoryl pyruvate. Then once you get to phosphoryl pyruvate, you can pretty much go all the way up to fructose 1,6-bisphosphate. Okay. That's a second reaction there, that PFK, that is not reversible. So that's another roadblock. And then the last one is, if you really care about making glucose, it's just removing the phosphate from glucose 6-phosphate to give you free glucose. For the vast majority of cells, actually, they don't need to worry about step 1. And if you remember why that is because the whole point of phosphorylating glucose at the first place with hexokinase was to stick a negative charge on glucose so it cannot get out and the cell keeps bringing it in. This becomes an issue if your job as a cell is to provide glucose to others. So you want it to get out of you and provide it to others. So it does happen in the liver. But for almost pretty much every other cell, only the pyruvate kinase reaction and phosphofructokinase reaction need to be reversed, or figure out a way around them to bypass them. Really, they don't get reversed, but you just have to bypass them. So in most microbes, as I said, it ends in glucose 6-phosphate, so no hexokinase bypass. So we're going to start in the next video and see how pyruvate kinase is bypassed, which is by far the most complicated one. So at this point, we'll stop.